Project Determine is a joint project between Cranfield University and UCL, and it provides the funding for 2 PhD students, one based at Cranfield and one based at UCL. The overall aim of Project Determine is to develop new forms of bistatic and multistatic ground-penetrating radar systems that have an enhanced detection and classification performance as compared with conventional ground-penetrating radar.
Traditionally, GPR uses a radar mounted very close to the surface and looking straight down at the landmines. GPR involves people on the ground in often very hazardous areas. If you think about a patch of ground, the only thing that changes is the soil moisture. So the soil moisture goes up and down as it gets wet, then dries again. Something that's underground will actually respond in sympathy with the soil moisture, whereas something on the surface won't. We've carried that on to develop a new technique called virtual bandwidth synthetic aperture radar, which actually then takes this one step further. We can actually resolve the targets below the surface because they'll show different delays in time due to this soil moisture effect.
The type of science involved in this project is essentially the development of novel wideband type antennas that will work with our ground penetrating radar setups, whether they be tomographic or bistatic, but also the algorithms that are used to produce the super resolution imaging will also be very much more advanced than classic SAR or synthetic aperture radar type algorithms or very conventional inversion type algorithms such as time tomography and other more basic types of inversion algorithm.
What we want to do is try to develop a system which uses a standoff capability so we could actually do this remotely from an aircraft or a satellite. This technique is really being as a wide area surveillance tool, so you can, if you suspect there's something, you can use satellites or aircraft to build up a picture before you actually commit to looking into that and that's a very important way of doing it.
With the financial support of Find a Better Way, we've been able to fund a full PhD studentship. It's also provided us with the capital to basically build and develop our new form of bistatic and multistatic scanning systems. I've seen close at hand the level of mines laid out on the border between South Africa and Namibia, where you can have up to potentially 4 mines per square metre. It denies access for the local people to do farming or to grow crops or move their animals across that type of ground. This is a true and a unique opportunity to work on advanced science and imaging algorithms, which has got a humanitarian cause at its heart.
Naturally, this is a very emotive subject, but the problem is still going on even after these years, and at current rates it's going to take decades to actually clear these areas. So any step change in that capability will have an immediate pull through to people on the ground and actually saving lives and improving lives. I'm Keith Morrison and I'm helping to find a better way.
I'm Ivor Morrow and I'm helping to find a better way.